Hello friends, welcome to our YouTube channel Deadly Coder. Today in this video we will be discussing the solution to the problems A, B and C of the latest Codeforces educational round. So the first problem is long comparison. Basically, let me go through the question quickly. The question says that you are given two numbers written on the whiteboard and we need to compare them. But the numbers follow a specific pattern, like a positive integer x with p zeros appended to its end. Okay, so right then Monocarp wrote down on the blackboard two numbers, and both numbers follow a specific format, a positive integer x with p zeros appended to its end, and we need to compare them, right? Depending on their comparison, if the first number is smaller than the second one, we need to print a lesser than sign. If the first number is greater, print the greater sign. If they are equal, we need to just print the equal to sign, right? So for solving this problem, what we can do, that we can just check how do we in general compare two numbers. Like if we have 34 and if we have, let's say, 567, how do we know that the second number is greater, or alternatively how do we know that the first number is lesser than the second one? Okay, similarly, if we have the other way around, like 567 and 34, then we know that the first number is basically greater. So basically from these two things, one thing is clear, that if we say that the number of digits in x1 is greater than the number of digits in x2, then we can say for sure that x1 is greater than x2. Okay, so this was the first observation. Okay, this was the observation number one, right? And also, if the digits in x1 is lesser than the number of digits in x2, then that implies that x1 is lesser than x2, right? So this is the first thing we can do, right? We can first of all how many digits are in the first number. Actually, x1, from by x1 I mean to say the first number, and by x2 I mean the second number. Okay, so this was the first thing which I did. First of all, I find what will be the length of the first number, right? And as we know that the number follows a specific pattern, like x1 followed by p1 number of 0, right? This was the pattern, right? So what will be the length of this entire number? That will be nothing but how many digits are there in x1 plus there are 0 number of p1 number of zeros. So we will just add p1 to it, right? And for counting how many digits there are in a particular number, we can just keep on dividing x1 by 10 until it is greater than 0. Okay, that's a very standard approach. So I defined a function length which will calculate what will be the number of digits in x. So if the number of digits in x plus p1, so that will give the total number of digits in the first number. If it is greater than the total number of digits in the second number, print greater than sign. If it is smaller than, then print lesser than sign. And there comes the next thing, right? So what happens if the number of digits in x1, so let's not call it x1 x2, that might be confusing. Let's call it x and y. So that will be more clearer for us to understand then. So what happens if the digits of x is equal to the number of digits in y, right? So if it is so, then we can just compare them lexicographically. So what what do you mean by lexicographically? Is like this. Let's say the first number is 56 and followed by, let's say four number of zeros, right? And let's say the seven number is 123 followed by three number of zeros, right? So obviously the length of the first number is equal to the, or you can say the count of digits in the first number is equal to the number of digits in the second number. So how do we compare them? So basically what we can do is that we can just store them in some string, like let's say we store it in some string like s, and let's say we also store the second number in some kind of string. So now what we can do, we can just simply compare them, right? And there is a function like we can just simply say if s is lesser than t, then print this. If s is greater than t, then we can print this, else equal to. but uh, but the thing which may be noted is that since p1 and p2 can be arbitrarily large, like p2 can be like 10 to the power 6. The thing to be noticed here is that we don't actually need to uh, store the entire string. Why? Because let's say this was my p1 over here, and let's say this was p2 over here, right? So the thing is that we only need to compare this part, right? We only need to compare this part of string, right? We only need to compare this part of string, because let's after this p2, let's say this p2, like everything is 0, and here also everything is 0. So there is no means of comparing, there is no sense of comparing them. So we just only compare the first, what you can say, uh, the we just only need to compare these this set of digits, right? So this is what I have done over here. Like we take two strings s and t, we just converted them to string. This is a function in C++, to string, which returns a string and takes an argument as a number, returns a string, and while their sizes are not equal, I am appending proper number of zeros. For example, over here, if let's say if x1, let's say if x1 is equal to 56 and x2 is equal to 123, so since their sizes are not equal, I append a 0 to this. Now their sizes are equal, and now I can just compare these two, right? So that's what, while the s dot size is not equal to t dot size, depending on whose size is smaller, I will append 0 to the smaller one. And after doing all these things, I just compare them, right? I just compare them, and depending upon the result of comparison, I just output the corresponding operator. So that was all about question number A. Let's move to question number 2. So the question number 2 is absent remainder, and basically in this problem we are given an array, or you can say a sequence of n integers a1 to an, and all of these are pairwise distinct positive integers, right? So we need to find n by 2 different pairs of integer x and y such that x is not equal to y, x and y appear in A, and x mod y doesn't appear in A. Okay, so this is problem B. So let's say, so we are given basically a sequence like a1, a2, a3, so and so up to an, right? And we need to find basically n by 2 pairs, right? We need to find n by 2 pairs, right? And such that if let's say if there is a pair x comma y, then both x and y should be from this array only, and x modulo y should not appear, should not appear in the array. Okay, so this is the thing which is required. So the first thing to be noticed, so the first observation, so the observation number 1, the first observation is like x will always be greater than or equal to y, right? It's like the first observation, x should always be greater than y. Why? Because Because if we assume that x is lesser than y, then that would mean that x modulo y will be equal to x, because any smaller number modulo a larger number is the smaller number itself, right? But x modulo y is x, and x is one of the array elements, so again that will imply that x modulo y is present in the array, so which is invalid, right? So which is an invalid. So that's why so that's why in an ideal case, or any pair which will be a part of our answer will always be having x and y such that x will be greater than or equal to y, right? Okay. So the next observation, so this was the first observation. The observation number 2 is that now we know that the first element of our pair, so if our pair is, let's say, xy, right? If this is our pair, which is one of the answer, we know that x will be greater than or equal to y, right? Now we also know that x modulo y is always lesser than y, right? This is the property of modulo, right? So so if we set y is equal to smallest element of array. So if we set y is equal to smallest element of array, then we know that x modulo y will be lesser than y, right? And since we have set y to be the smallest element, we know that x modulo y will also be lesser than the smallest element. And so this implies that x modulo y will not exist in the array, so which satisfies our condition, because this was most probably what we wanted that x modulo y should not exist in the array, right? So in this way we can arrive at a solution. What we will do, we will just sort this array, right? So let's say after sorting, the array looks like this, like a1, then a2, then a3, so on and so up to an. So now we will just print n by 2 pairs, right? And what in each pair will be of this form, like a2 comma a1, then a3 comma a1, then a4 comma a1, right? So so in this way we will just print n by 2 such pairs, right? So, and obviously all of these will satisfy this condition, right? We know that a2, a3, a4, all of them will be greater than a1. So observation 1 will hold. And since we have set y to be the smallest element of the array, which is here a of 1, right? Then obviously taking the modulo will be resulting in a element which will be even lesser than smallest element, and that will surely not exist. So in this way we can arrive at a solution. So you can see my code for this. So basically just take input n, array n declared, taken all the elements in the array, just sorted it, and just printed n by 2 elements, right? ai and a of 0. So obviously you can also see that not only n by 2 pairs, not only n by 2 pairs, you can actually find even n minus 1 pairs, right? With this observation you can find even n minus 1 pairs. So that was all about question number 2. Let's move to question number C. This was poison dagger. Let's go through the question quickly. Okay, actually in this problem there is a dragon, right? And there is a character called Monocarp. Monocarp wants to kill the dragon, and the dragon, the battle with dragon lasts like 10 to the 100 to the power 500 seconds, which means it will last for infinite time. The ith attack is performed at the beginning of a ith second from the battle. The dagger itself does not deal damage, but it applies effect on the dragon, which deals 1 damage during each of the next k seconds. Okay, so this was problem B. Now let's move to problem number C. So this is problem C. So basically, in this problem, what it means is that let's say I attack at AI second, right? AIth second, then it will cause a damage to the dragon for upcoming upcoming k seconds, right? Which means stabbing a dagger on the dragon, it will cause damage on the AIth second, then A of I plus 1th second, so and so up to A of I plus k minus 1th second. 1th second. Okay. Yeah, this is the thing. Like putting a dagger on the dragon will cause a damage starting from the AIth second and ending up to A of I plus k minus. It means that it will cause damage for the first k seconds, right? So it will cause damage for the next k seconds, starting with the same second when the dragon was stabbed by the dragon. However, if the dragon has already been poisoned, the dagger updates the poison effect, right? So we are also given an example like if k is equal to 4 and the dragon stabs the dragon during seconds 2, 4, and 10, then the poison effect is applied at the start of the second and deals 1 damage during the second and third seconds. Then at the beginning of the fourth second, the poison effect is reapplied. So it is basically just the demonstration of the problem, that how it will actually happen, right? For example, let us see the given example only, that how will it actually work. For example, uh, if k is equal to 4, let's say. So if k is equal to 4, if k is equal to 4 and the dragon stabs the dragon, monocarp stabs the dragon during seconds 2, 4, and 10. So 2, 4, and 10. So this is the time stamp during which I will be stabbing my dragon. So if I just put the if I just stab the dragon during the 2th second, then it will actually cause the damage starting from the 2 second, then third second, then fourth second, and then fifth second. So this should basically what should happen, right? But when I reach 4, right? When I reach 4, I see that I again stab the dragon during the fourth second also, right? So now what it means is that 2, 3, 4, 5, 6, and 7. So this will cause damaging effect for 4 seconds starting from the fourth second, right? So this will happen again, right? And then on the 8th second there will nothing happen, 9th second also nothing will happen, then at the 10th second again I stab the dragon, so it will cause damaging effect to the dragon, starting from 10th second, then 11th second, then 12th, then 13th second, right? So this is how the things will proceed. So as you can see, the dragon receives a total of 10 damage, right? You can also count it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it caused a damage of total 10 10 units, right? So monocarp knows that the dragon has h hit points, and if he deals at least h damage to the dragon during the battle, then he slays the dragon. Monocarp has not decided the strength of the points he will use. So he wants to find the minimum possible value of K that is enough to deal at least H damage, right? We have just taken, this is a very sample procedure way to take the inputs. We are taking N, H, then this array, like the array is completely sorted, right? A of I is lesser than A of I plus 1. We need to just print the minimum value of K, right? So the thing is that here the K is unknown. We don't know what will be the value of K, and we want to minimize the value of K, right? So the first observation, so the first observation is that uh, if if using K is equal to, let's say, X, right? If using K is equal to X, I can I can give uh, H units H units, or you can say I can give at least H units of damage. Then that implies that using any K, like using any K which is greater than X, also will do the same, right? So this suggests that we can actually use binary search, right? Because this is the important criteria of binary search. We can just do binary search on K, right? So this was the overall idea of the problem. Basically, we will just do binary search on K, right? So we just fix some mid value, right? And we try to find that if I can I can yield yield damage to the dragon for continuously mid seconds, then what will be the maximum number of damage I can, in total, what can be the maximum number of damage I can give to the dragon. If that is greater than or equal to H, then mid can be my possible answer, and I just reduce my search space. Otherwise, if using K is equal to mid, if I can't obtain at least H units of damage, then I need to increase my search space, or you can say then I need to search for increasing value of K. So in that case, I will just set my load to be mid plus 1. So I just set my search space to a higher region. Okay, and this is all what we need to do in the problem C. So basically, just I have taken N and H, taken the array, declared some answer. There is some low and high, right? So high will actually be infinity, right? And infinity in this case, like I have assumed infinity to be 10 to the power 18, right? Now the reason for this is that H is 10 to the power 18, so it's around that thing. So that's why I have declared K to be 10 to the power 18, right? And then just doing that standard binary search, finding the mid, and then just calculating what will be the damage if I use K is equal to mid, right? So this is also important to know how we can actually calculate this damage, right? So let us see. So so let's say if I stab the dragon at A1, A2, A3, A3, A4, like something like this, or to a nth second, right? So if I stab the dragon during these seconds, and let's say if my K is fixed, right? Then how do we know what will be the maximum number of damage that I can give to the dragon, right? How do we know? So basically, as soon as I hit the dragon at the A1th second, right? If I just hit the dragon at the A1th second, then it will yield damage, right, up to k units of time, right, to k units of time. And let's say my a2 is here, right, a2 is here. So if a1 and if a1 plus k, so if a1 plus k is lesser than a2, right, if a1 plus k is lesser than a2, then we know that i I just gave my dragon k units of damage, right. So in that case my damage will be incremented by k, right. But let's consider another case. Let's say if my a2 is here, right. So if a2 is here, then although stabbing the dragon at the a1 in second should actually yield a damage of k units, but actually it will only yield a damage of a2 minus a1 units. Why? Because as soon as I reaches a2, the effect is reapplied, right. Some another process starts again with a2 considering as a start point and continuing for k seconds. So that's why what we do, we just took the minimum of this, whichever is the minimum of this, we just add that to our damage, right. Actually you can also do this using two if conditions, like first checking if a1 plus k is lesser than a2, then add k to the damage, else add a2 minus a1 to the damage. Or alternatively you can just also do this thing, right. You don't check those two conditions using if, you just simply do this, like damage plus is equal to minimum of k comma a2 minus, not a2, basically it should be ai plus 1 minus ai, right. You just simply do this and keep on adding the things, right. But keep care of one thing, that if you are at the last second, right, then if you just apply the stabbing on the dragon at the last second, then it will for sure cause you a damage of k seconds only, right. So in that case you just only need to add k to the damage. So this is what I have done, like just iterated from beginning of the array till the end. If I am at the last second, then I will just simply add whatever is the value of my k. So currently I am considering k to be mid, so just add that to your answer. Else simply add a of I plus 1 minus ai comma mid, the minimum of those two, to your damage. And at the end just check if this damage is at least h or not. If it is at least h, then yes, your answer can be mid. Otherwise, if this much damage, uh otherwise if okay, else means if damage is lesser than h, if the damage is not sufficient, uh, just simply set low to be mid plus 1, which means search for some increasing value of k. And if you know that your damage is already greater than or equal to h, then you just simply check the possibility of some lower value of k, which can also yield you a damage which is at least h or not, and at the end you just print it. So yeah, this was all about problem c. I hope you enjoyed the problem. If you really liked my solution to these problems, please like, share and subscribe our channel. Thank you.